Hey, James.
Oh my God. Oh my, sorry.
Hey,
Oh,
Lucas.
I'm not muted. I'm sitting here cracking up at Sebastian just sent me. He's,
What?
what do you think? Check it out here. I'll share this. He goes, what do you think? What do you think about this art he made for tomorrow?
Super. Awesome.
That's funny.
Man,
Lucas.
this is exactly what Jimbo needs. You know, me and the world of
The music vibes are great. Great.
What do you think about that? What do you think about the team configuration?
Yeah.
I think the music one is really nice.
Yeah, I like that one too. Hey, Yuli. Hey, Nelson, what's going on? All right.
Just a word to Nelson. So I was speaking with a colleague, what's his name? Nishan. Maybe he'll reach out to you to do sort of a study group or something. Okay, because he's on your time zone almost.
Yeah, that's great.
Yep.
Thanks.
Cheers. Let me know if he doesn't reach out. Maybe I can try to put you guys in contact. Okay.
Cool.
Cheers.
And hey, I'm just catching up with the student chat from a few minutes ago. And Yuli, I noticed this problem yesterday as well with Cardano scan testnet. And it happened right around the same time that my node 1.35.3 stopped working. So I don't know exactly why Cardano scan testnet was being a little funky lately. But I can't help but hypothesize that maybe there was some tweak to the network yesterday that kind of brought Cardano scan down. And like you, I could see it on the testnet explorer. Oh no, like Saurabh said he could see it on the testnet explorer, but not Cardano scan. I had the same experience.
Yeah, I minted my tokens, but they are not visible on Cardano scan. So yeah. We will see. Maybe they're updating something, or I don't know.
You know, but this is such an interesting philosophical question too. It's like, okay, when is it real? Is it real when I can see it in my wallet? Is it real when I can see it on Cardano scan? You know, most people think that NFTs don't exist unless they can see them on Pool PM, right? So
Yeah. So I don't know.
So I talked for like, I don't know, an hour and a half straight yesterday, demonstrating a bit about transactions, and I'd rather not talk that much today. So the first thing I'm wondering about is now that folks have kind of seen that process, especially if you were seeing it yesterday for the first time, what have you been thinking about regarding transactions and smart contracts since yesterday's live coding, or just as you work through some of the other course material?
So what I'm thinking about is it, you told about when you don't set the datum hash, then you can't get the ADA back from the contract. Is it that way?
That's right. And you know, every time we talk about that, this to me, it feels like a major design flaw. Like it still doesn't I never was able to believe it at first, but I've seen it in practice, and it doesn't feel right that it should be possible to accidentally send a UTXO to a smart contract and make it irretrievable. But that is the current state. I don't know if it'll be that way forever, but yeah,
Well,
that's
It's
exactly
not
how it is.
validated by the CLI or something.
Right. I wish, right? But it
Mm.
is. I just did it to myself the other day because I was trying to move too quickly, and on that relocking transaction, right, where we pull a certain amount of funds from the faucet and we send the UTXO back. The first time I wrote that transaction, I just forgot to put the datum hash on. And so now I have just testnet tokens that are stuck there. And I'm grateful for testnet, right? Because I wouldn't want to make that mistake on mainnet. But it just, yeah, it doesn't feel right.
I don't know, the datum hash is then saved in the context, I think, huh?
That's
And
right.
when you send the wrong datum hash, when you send the wrong one, then you can't access the contract. So the transaction will fail.
Right.
But if you send no datum hash, I don't know.
Well, it gets even more interesting. With no datum hash, we're stuck, we're out of luck. But then even with a datum type mismatch, right? I can write a contract like the faucet one that I showed you yesterday that requires an integer as datum. But then if I create a datum from something other than an integer, now my validator logic is going to fail,
Yeah.
even though it's irrelevant, right, to my actual business logic.
Yeah.
So this is right. I think the main point here is we have a pretty big responsibility as we start building automation of transaction building, in this case on our front end, to make sure that we're getting those details right. And that's why it's good to have this chance to kind of test these ideas together. Nelson, your hand was up and somebody else's hand was just up.
Hi, James.
Hey.
Yeah, so I was thinking, I haven't been able, I don't know how to go through the Plutus script yet, but I just wanted to ask, the one we have now, the faucet template, if we move the PPBL token to another wallet and then try to mint another maximum amount from that contract, does that still work? Or have you written a restricted code for it?
Excellent question. Okay, so yeah, if the faucet contract as it currently exists makes no distinction between addresses. Okay, so if you move your PPBL summer 2022 token to another address, then from that address you'll be able to withdraw from the faucet. It's the security or the token gating of the smart contract is only relying upon the existence of that token in the incoming UTXO. And it doesn't care at all about where that's coming from. The reason this question is so important is because this starts to drive us deeper into the problems of identity, self-sovereign identity. So you might hear the acronym SSID, or you might hear about decentralized identifiers, DIDs. Okay, this is the main problem that SSID has to solve, is not just can I create a token that represents, somebody having done something or earned some right or privilege, but I also have to build out the part that says, hey, the holder of this person is the person who ought to be holding it. And so we got to work on that problem. the Ethereum community is talking about, they refer to it as proof of soul, right? How do I prove that I am the soul that ought to own this thing? So whether or not you like that terminology, we know it's a major problem. And it's a problem that, you know, I introduced the credential project. And the first thing, right? So during that NFT module, the last discussion there just asks you to share your thinking about what you might want to have on a PPBL credential token. And we're going to make those tokens at the end of this course. And part of the reason we're doing that is just because we can, right? We can start to define a standard together. We can give these things out to each other. But the other reason, kind of the longer term reason for doing it this way, is I want to force the issue, right? I want to start putting credentials out there and allowing us all to experience, hey, Nelson, you earned this, you know, credential for completing the course and it's on mainnet, but how do I know that you're Nelson, right? And I think we have a better ability to ask that question once we force ourselves to. And so, you know, there's a little bit of kind of pushing that agenda here, that once these things are in our hands, we're going to be better equipped to build the real solutions. Roberto, what's up?
Hey guys, I was just thinking with regards to that question, we were just talking about the problem of tokens getting stuck in this place and they're irretrievable, right? And that means they can't be transferred. And that's, to me, that's kind of the question with DIDs, is that they should not be able to be transferable. You shouldn't be able to sell your diploma that credits you with some sort of education, right? So why can't that same principle be used for identification? Whereas once that token is distributed, it's no longer distributable. And I was looking at the minting script policy that we were using, the one that I think outputs right or left. No, the one we're using for token. I was looking at it. It's really simple, right? And I never really thought about what can be done with the minting script policy. How much is it just like any other, like the validator code where you can do, is this offline, or I think this is off chain, right? Can you pretty much, is it flexible? Is it just, can you do pretty much anything you could do with like a validator in terms of setting up conditions and that kind of thing?
Brilliant. Okay. Wow. Dude, I'm so glad we are here right now and that we get to have these conversations. So to both of those briefly, and then I want to get thoughts from other folks. I've never thought of that before. This ability that we might be able to permanently lock a token at a contract address in the way that you just said, and therefore be able to trust that its holder is who we think they are. That's a big, innovative idea. And the reason I'm excited about it is that with the capabilities of the Alonzo era blockchain, that's not yet possible, okay? Because in order to verify the existence of a given token within a UTXO, we must consume the UTXO. And so what we're talking about in terms of, hey, if I don't include datum on a UTXO at a contract, it's not consumable, and therefore I can't look at it, right? But maybe that's about to change. The Babbage era is introducing for the first time the ability to reference things without consuming them. And so, yeah, does that mean I can put a UTXO at a contract address with no datum on it and therefore know that it's guaranteed to always be there? And then can I reference it without that? That would open up a lot of opportunities if that was the case. And it would make a heck of a lot of sense that there was this technical possibility. That's yeah, Dom, What do you think? I might be driving you crazy right now with this open speculation.
No. This is, bro. This is Roberto. When I heard that, my head exploded. I was like, oh my goodness, yeah. Especially when you consider like everyone maybe minting an individual script address. Now there's verification to how you verify that to that person. So I'm seeing a little bit of complications. But just to have something like, you could look at a script, you could look at an NFT and pull PM in a script contract, and you could see that you could look at the picture, you could see the metadata, you just couldn't do anything with it. So now you're like, do we set up verified contracts that a third party makes? And all these contracts do is it's just a wallet to hold your dids, and none of them have a datum on them. You can't put a datum on them, and that's your script contract. I mean, like, bro.
This is wild speculation, but fascinating for sure. Yeah. Other Dom, what do you think?
I think you can already do this, and you wouldn't do it that way. You'd have a script address that can only works if it sends its content back to itself, right? So it's got a token in it, and it goes back to itself. So you can't spend it from that address, which I think is like how I want to say how Ethereum NFTs work. They're held somewhere else, but I don't actually know, so I should just not say that. But regarding the read-only UTXO, I assume it's still living at an address and it still is validated. It's just not spent. Maybe is code not still executed when you call that UTXO?
Yeah, that's my question too. And
so I think I don't know how the not spending works, whether you can say, I guess your script can say it mustn't spend this thing. Sure, but you can do this idea of like leaving a token at an address, which can be involved in transactions, but never leaves that address. And that's how state machines work as implemented in Plutus.
very good. Yep. Does that make sense to folks? Like the basic functionality that Dom is describing here, you can write into your Plutus logic that a certain, that a contract can only spend assets back to itself. Does that raise new clarifying questions for anybody here?
Yeah, so you can specify in a Plutus script that whatever tokens you mint, you can only send to yourself.
You can specify in a Plutus script that anything spent from that script must return back to that script. So it's almost like it's not being, it's not moving, right? So I can lock some identity token or credential token or whatever the heck else I want at a script, and I can ensure that it's impossible to then remove it from that address. Of course, what that means is anything that gets sent there won't be able to be removed from it, right? And there's other ways, there's additional logic that we could add to Plutus to say, well, if an asset with this policy ID is sent to this address, then it can only be returned to this address, right? So there's additional guards that you would definitely want to create there, just so that, other assets wouldn't be inadvertently locked there. But yeah, that's a helpful concept, Dom. Thanks. Roberto, your other question was about native scripts, and you're exactly right. I'm really glad that kind of helped you think about the potential of native scripts. And this is why, when Plutus was imminent but hadn't yet arrived, there was a strong chorus of people saying, hey, we don't even need Plutus. Why do we need that? We've already got native scripts, we've already got metadata, and look at how much you can do with those two tools. And I think that's a really interesting question for people to explore. I wouldn't want to be like artificially wedded to that idea for too long in a course like this, but as an optional exploration, building a DApp and seeing how much you can do without even touching Plutus is a great way to learn about what these tools do. And when you are introduced to native scripts in this course, it's in the context of token minting, right? We can say, all right, I can add a bunch of signatures that are required to mint a token. But in the very same way, you can collect a bunch of pub key hashes, you can put them in a native script, and then you can use that native script to create a new Cardano address. And that new Cardano address is by definition a multi-sig address, so that anytime you want to unlock UTXOs from there, you'll need all the signatures of the people specified in the script. And so that's functionality that a lot of people who have been, developing since pre-Plutus, but even building basic multi-sig options, that's absolutely a design pattern that a lot of people have used.
And I imagine that Plutus script, it would be very much involved in how you would design your validator and your off-chain code in terms of it has to be all connected, right? Whatever you think about in your Plutus script, you need to think about in terms of how that's going to go through your validator.
Right. Well, so your Plutus. So I want to distinguish between native scripts and Plutus scripts, right? So that native script, and maybe it's worth sharing a screen here, but it's just that it's a JSON formatted file that just says this sig and that sig, right? Or invalid before or invalid after. That all of that native scripting functionality predates Plutus, and in fact, some of that is available even on Bitcoin. Okay, but the Plutus part is what allows us to get exponentially more robust with the possibilities that we're able to include, right? Instead of just using signatures and time slots, now we have the ability to add any logic, and multi-sig addresses can be created in Plutus, right? You could absolutely write a Plutus script that just says, hey, you can only spend from this contract if this set of signatures is included on the unlocking transaction. But you probably wouldn't want to do that. It would actually be less efficient to take that approach to multi-sig than to just use a native script to slap a couple of signatures together and see how that works. It makes me think that, maybe an exercise we would want to do in a live coding together would just be to build a multi-sig transaction. And we could even pass the partially signed transaction around to each other, let a couple of different people sign it, and see how that would allow us to unlock that.
That would be really fun.
All right, let's put that on the upcoming agenda. I would have to scramble a little bit to do that right now. I just want to make sure I prepare us for that. But yeah, let's have that coming up. One of the reasons I like that idea of that exercise is, in my experience, I've gotten a lot more confident thinking about Cardano development as I understand each component as just a bit of data, right? Transactions really felt magical to me until I realized that they were just pretty small files, right? It's just a string, and I can, as such, I can pass that transaction to anybody. So learning about how cold storage works is a really interesting way to do this. Early on, maybe 2 years ago, Charles made a video just showing people that for max security, you can build a transaction on a machine that's connected to the internet, but then you can put that transaction on an external device, and you can take that transaction over to a computer that's never been connected to the internet, where you can sign it, and then you can take that signed transaction and transfer it back to your networked computer, where finally you can submit it to the chain, right? That's such a good exercise to go through. It's absolutely, maybe it's tied with having a hardware wallet, right? For being the best way to secure any amount of value. Yeah, but absolutely applies to Plutus scripts as well, right? A compiled Plutus script that was compiled on any given machine can now be passed around, can be sent around as a file that just other people can use. And I think, really spending time with that idea can build up your confidence. Oh, nice. Nicholas, you found this example. The idea of the loop, keep in mind versioning. Yeah. So versioning is a good question. Is it true? I've been operating with the assumption that Plutus will always be backwards compatible, right? There's never going to be a point at which a version of the Cardano protocol is going to be released that no longer allows me to use a Plutus script that was compiled several eras ago. And I think it has to be that way, right? There's already smart contracts running. There's real value being locked in those contracts. And those contracts, they refer to a particular Plutus script that was compiled way back whenever, right? And so we can't introduce changes that would make those incompatible. What the upgrades do with each version is they just introduce options of more cost-effective ways of building transactions, right? So we could march into the Babbage era after the Vassal hard fork on mainnet, and we could just keep using Plutus V1 if we wanted to, but it would be foolish to do so, because if we did, we would be spending whatever factor more on transaction fees. And if we're trying to build sustainable dApps and businesses, that's a bad choice, right? So the market pushes us to adopt the new tool, but the protocol doesn't prevent us from using the old ones.
Yeah, I meant more, both on a Plutus level, but also just on a scripting level, because like how you've defined your functions, you might want to somehow evolve those. And if, say, for example, as Dom said, if it's a did, you really don't want to accrue a whole bunch of reputation and then like not be able to tap into that, possibly, I think. But yeah, I'm sure there are ways, but I'm just kind of throwing it out there as a thing to keep in mind.
That's good. So there were two things I thought we might do today. One would be to kind of stay in the Plutus side and look function by function through that faucet contract that we built transactions for yesterday, right? I gave you a really cursory overview of the Plutus code, but we haven't really looked at each of those Plutus functions in the documentation. And so that could be a really interesting way to go. The other option would be to build upon what we did with transactions yesterday and to apply it to starting to build some transactions in the front end template. Both of those are necessary use of time over the next few weeks, but does anybody have a strong opinion about which one we focus on today?
I don't know when we do it, but I'm really looking forward to the front end transaction building. I was really looking forward to that.
I hear 1 vote for front-end transaction building. I see a thumbs up for 2. 3. All right, let's play with the front end. That seems like enough. A's happy about it. All right. All right. Just gotta join in over here. Oops. Okay. So this is where we left off yesterday. And I'm going to keep this file open for us. If I want to interact with a contract, of course, I need a locking transaction and an unlocking transaction. And these are the 2 sorts of transactions that we might want to automate on a front end. Now, I say we might want to automate them because it's conceivable to build a DApp with some kind of front end UI where you're not concerned with locking. I could argue that the faucet is an example of this, right? I don't need to build a web interface for locking funds at a faucet if people can just lock funds this way on Cardano CLI. But I certainly want to create a front end that allows people to unlock from this or that faucet. Now, we're going to build the locking front end anyway for 2 reasons. 1, this course is more about learning than building real business utility. I want you to be exposed to as many things as possible. So obviously, from a learning perspective, it's in our best interest to build this thing on the front end. But 2 is accessibility. Not everybody has a node running locally, and so they don't have the ability to run this command locally. So we might as well open access further to some of these tools by building front ends so that people can kind of use this contract from anywhere. So we'll start by thinking about a locking transaction, and then we'll move to unlocking. Now, this is, whoops. I mentioned yesterday, right? We're in this incredibly interesting moment right now because tools are being released as we speak. Okay, so Abdel Karim just let me know that the latest version, where am I supposed to be here? The latest version of Mesh was just released. I don't think there's supposed to be any breaking changes, but right, I've already got the template here on this device. You can always run git pull to make sure you're up to date and to pull down the latest changes. But if I want to upgrade a particular package like this one, I can just run yarn add and add it again. And let's just watch that beta.3 number and see if it changes. Oh, look, we just skipped over 4 and we're right into beta number 5. Okay, so now I know I have the latest version of Mesh installed in this project. I'll push any changes we make today to the live repo so that when you pull this down, this will update in your package.json. but you might still want to run yarn after you run git pull, just to make sure that all those updates are made. And if you ever run into any errors where, you know, your browser or your terminal is telling you that it can't find a particular package or function from a package, it's likely because of this. And so just reach out for help. If you're new to front-end development, it can be a little overwhelming to kind of read your package JSON file and keep things up to date. But you do it a few times, it gets easier. And so I'll be happy to help out anybody who needs that. That's good for package JSON. We've got the latest version of Mesh. And so now my next goal, let's, we have this transactions page. I covered this in just the introduction to transactions video. I don't know if people have watched that yet, but feel free to raise your hand or just interrupt me if you've already seen that and you have new questions. I want to look at just a multi-asset transaction for a moment. Okay, I'm gonna rely on you to review the video to look at these very simple transactions, and let's jump straight to this one, because there's a few concepts for us to touch. So this is our transaction logic in the front end. And there's a lot of boilerplate that you'll start to recognize here. And maybe you would do things slightly differently than it's set up here, right? But just to kind of think through at a high level what we have here. Mesh provides a transaction service. It's one of the things we can import from Mesh. What is a transaction service? It's basically giving us the ability to build a transaction. And the way we build a transaction is through a series of functions that indicate what we want to do or add to that transaction. So this one says, okay, this is just the name of some data that is created by the transaction service. It makes sense to call this a TX, but of course you could call it anything. And we are referencing that TX once it's initialized down here at the TX build step. And so let's start at the end. Okay. What did we do yesterday? We built, and then we signed that built transaction. And then finally, we submitted it. Even Cardano CLI is an abstraction of these steps, right? Cardano CLI transaction sign is a function that was written in a language called Rust. And that Rust code indicates what it means to sign a transaction, how that works. In a similar way, here we see sign a transaction. And so Mesh provides this for us, right? There's some logic that has to happen in order for a transaction to be signed, but that logic is the same every time. It just involves serializing and deserializing things in the right way and grabbing a signature from the user's connected wallet in a way that outputs a signed transaction that can then be submitted. So just like Cardano CLI gives us easy access to these fundamental tools, signing and submitting, Mesh does the same thing, right? And this is such, I mean, this is a miracle upgrade right here to be able to do this in such a straightforward way. If you're building a dApp and you have real ideas about the logic that you want to deliver, you don't want to reinvent the wheel every time. You just want to be able to sign and submit your transactions. So that's what we're able to do here. that's probably all I'll ever say about this, unless we want to talk a little bit about multi-sig. But putting that aside for now, the real work is happening here. What's interesting to me about this is that I can see some of what looks familiar over here. And let's, keep in mind, this is already a more complicated transaction because it has this contract interaction right here, okay? So we're not talking about a contract interaction yet, but I hope you can still see some things that are missing from this logic in the front end. I initialize a wallet, and then all I have to do is run this send value function. And what does send value do? Well, it takes an address and some kind of value, and it builds the rest of the transaction for me. What's missing from this? Hopefully you recognize that nowhere did I have to identify my UTXOs in. And so this question came up. I was glad that people asked about this yesterday while I was sitting there looking like a fool, choosing transactions by hand. Thank goodness we don't have to choose UTXOs by hand anymore, right? That's taken care of. That's taken care of because we have a CIP, shit, I always forget. Which one is the wallet standard? CIP 30? Okay, we have a CIP 30 standard that wallets adhere to, and those provide transaction selection or UTXO selection for us. And so already you can see the upgrade from doing things this long, exhaustive way to just saying, hey, I got a wallet and I want to send some value. I don't care which UTXOs that value comes from, as long as this value gets output. And under the hood, the right UTXOs are selected and change is sent back to the user. All right, so what questions do you have so far about that?
Are we using an API key to submit this?
We are not. Great question. Okay, so the guys, because it's easy and accessible, the first submit service they provided was Blockfrost here. But then they already added in this latest update a Koios provider as well. Koios exposes a submit API and then a bunch of other data consumption APIs, right? It's like a more limited version of what the full scale Cardano GraphQL provides, because there's a set of queries that you're just going to need to make all the time. And so Koios provides those for free. There is a rate limit to protect their servers from abuse, and they don't have a paid tier. But for anybody who's learning, Koios is plenty. And I absolutely recommend learning how to use it and using it in development. And so that's already, giving us other options. But the truth is, we don't need any sort of access to submit API when we're talking about browser wallets anyway, because the browser wallet hits up a submit endpoint and submits that transaction for us, right? The reason they wanted to do this, and I'll just say a word about this bit right here, initiator wallet. These guys are already thinking ahead to a point where browser wallets might not be the only way of interacting with a dApp, okay? They are the primary way right now to interact with web-based dApps. But of course, we can imagine a world where a dApp doesn't even need to connect to a wallet. Maybe the wallet functionality is hidden from the end user who is creating transactions that do go on Cardano, but without ever managing their own keys. That's a loaded issue right there. Who has custody of those keys now? And there's a lot more things we have to think about. But hopefully you can imagine a world where there are use cases where, yeah, I don't want to connect a wallet every time I want to use that app. I want to use that app, right? And so that kind of wallet functionality is being added to Mesh over time. And that's why we're going to need a variety of different initiators to start thinking about building those transactions. I think that's incredibly cool. All right, so now that we've taken a quick look at this basic format right here, the next thing I want to show you is that whatever we learn about these functions like send value, they can be chained together. So what if I wanted to create a multi-asset transaction? Here's how simple it is. Or sorry, this already is a multi-asset transaction because it has Lovelace, and some other asset. And by the way, what's the unit here? It's asset ID. And that asset ID is simply hard-coded into this TypeScript file, right? And so this is as simple as it gets. Which asset is this quick send token component going to send? This one. But clearly you don't have to hard code an asset into your components. You could make this dynamic. You could build a form where it can be cut and pasted. You could build the ability to look into the user's wallet, see what assets they have, and then choose from that set. And that's what's demonstrated in the Mesh playground. But I just wanted to show you the most simple version of it right here. We can hard code something and then just pass that as a variable down here. But, all right, now that we've covered that bit, right, all of these can be variables, right? I can pass a hard-coded value or a variable amount of ADA. And depending on how comfortable you are with front-end development, you can go as far as you want with this. I hope that along the way, like if you're new to React, you're just picking up some big ideas right here. But here's another big idea. I want a multi-output transaction. Here's what that looks like. I can copy this whole block of code. I can just tack it on right here. So transaction service dot send value, yep, dot send another value to another address, right, which I could specify with some other amount of ADA and some other asset or the same asset, right? If I want to quickly send a PBL summer 2022 token to a bunch of different people, I could just tack these together. So that feels pretty user-friendly to me. I'm excited about that bit. But similar to sending value, there are also functions for adding metadata to a transaction. And the code is going to look similar. Let me get rid of this change before I forget that I added it. Save that how it was. And let's look at a quick metadata example. This is a work in progress right here, but I just want you to see this bit, okay? So this, I didn't go over all of this logic right here. This is just kind of UI logic. We allow for a spinny wheel to show up while a transaction is in process. We check that we are indeed on testnet. And if the network is 1, that means we're on mainnet. So we alert the user that this thing only works on testnet. So you'll see that in all of these examples so far. And then of course, this part right here is unchanged. But in between, this transaction is the most basic example of just adding metadata to the chain. What can I do? I can just send Lovelace to myself. to the connected address. I can send 1 ADA, just a minimal transaction, and the cost of adding this metadata to the chain is just going to be the transaction fee. And then, similar to just chaining a bunch of send values or send Lovelaces together, I can then do dot send metadata right here. And this function makes metadata really easy as well. I provide a key and then a JSON stringified object in a valid metadata syntax. So just another idea that I wanted you to see for the first time. Let me catch up on the chat. There are a limit on the amount of transactions through the front end. Right. Not that I'm aware of, but only one way to find out, right? Let's try to push that limit and see how far we can push this thing. Curtis, what do you think?
Actually, I just had a question. When you were showing multiple outputs via the front end, when you added that second section and you pasted it, that's statically defining the front end, right? So would that then require 2 outputs if you had left the code the way you presented it?
That's right. That's right.
So I know you briefly, I think it was yesterday, went over how mesh allows you that button to add and like continue to add, but I didn't see how that looks in the front end code. How do we, you know, what minimum is 1 output, but then allow the user to just say add another, add another? Where does that button come from?
Excellent. Okay, yeah, that's a perfect thing for us to look at next. Okay, let's do this. I'm going to move over to my web browser. Sorry, Linux Zoom is incredibly hard to use. All right, let's try this one more time. And here's the browser. Okay. So let's look at the mesh code in just a minute. But first, to catch everybody else up, just in case you haven't seen this bit. But even if you have seen it, it might be worth taking a look right now. Okay, so I'm on the mesh playground, mesh.martify.io. I jumped into the transaction APIs here. And let's just look, for example, at multi-assets. And what's amazing about the mesh playground is that the guys have taken their own libraries to just make these awesome tools that allow you to kind of see the JavaScript you would need change in real time. Okay, so I want to send a multi-asset transaction with how much Lovelace? Let's do 2 ADA. And you can see right here that updates dynamically to show me what that send ADA or send Lovelace would look like. Okay. And if I change the address, that would change too. Now here, this is the first interesting thing for us to notice. I can get my wallet assets. And this is actually querying the actual NAMI wallet that I have connected right now. And you can see in this wallet, I've got PBL summer 2022. I've got Skycoin. I've got module 201. It looks like I might have a few NFTs as well. Cardano logo and hello Alonzo. So what's that? A total of 5 different assets. And that's exactly what I see right here. So when we go back to the code in the repo, one of the things I'd like to look at is, hey, how'd they do that? Let's figure that part out, okay? Now, what this does, now that I can see those assets, is I can add them to a transaction. So watch what happens down here when I click on Skycoin. Now it says send assets. And so I can say dot send Lovelace to this address and then dot send assets to the same address. And then inside, I see this object here. Well, it's an array of objects, each of which has a unit and a quantity. So if I add another asset, let's say Mary, right, that gets added to this array as the second object, once again with this unit, which is just policy ID and token name and a quantity. The way this is done is different in a subtle way from what I was just showing you over in my VS Code. I was using a function called send value. Here they're using send Lovelace for the Lovelace and send assets for the additional assets. And the way it's built, this is actually going to produce two unique UTXOs. One with 2 million Lovelace in it, and another with one of this token, one of this token, and some minimum ADA. So if I tried to send this transaction right now, my NAMI window would pop up. I think, let's see if that happens. It says I can run the code snippet. Oh, not enough ADA left over to include non-ADA assets. That's funny. That's not true though. You have to look at how it's managing my UTXOs to figure out why that happened. But that's, yeah, I don't want to use too much time on this right now because I don't know if this would happen if we did it locally. So let's just look at the syntax from, for now. And if this had worked right there, what I would be asked, is there too many zeros? No, there's the right amount of zeros. What my wallet would ask me to do is sign a transaction for probably about 3.4 ADA. The 2 ADA here, the 1.3 or so that would fulfill the min UTXO for these assets, and then a fee as well. If you wanted to produce just one UTXO with all of this, that's where you would use the send value function instead of the send Lovelace or the send assets. And we'll see that in practice as we move on. So now, what brought us here in the first place, Curtis was just talking about this add recipient button as well, right? So once again, watch what happens when I add a recipient. And what did it just do? It tacked on another send. Maybe I need to add some love. Oh, I need to add an address and some Lovelace before that actually gets added. Let's call this one fake address, and let's send 1 ADA to it, right? So this is just a text box. And as you can see, there's no validation right here that what I'm typing into the address box is actually an address. There is in the library. They've done a lot of type creation. And so I don't think this is possible on the back end, but it's possible right here. But as you can see, another send Lovelace just gets tacked on. Instead of using the address that was input into this box up here, we get the address that was typed into the next one. We can send Lovelace there. And then, of course, I can add assets once again. Fake address gets one of this token. Any clarifying questions about this before we jump into the code that they use to make this happen? Okay.
So I suppose just quickly, the coin selection, is that possibly what was bringing that error, or yeah, like how's that Like where is that happening?
Yeah, I hope so, right? Let's just run it again. Oh, missing human, yeah, I'm not using a real address. I think so, and the reason I'm not sweating it right now is building this playground perfectly is not their top development priority right now. So I'm not sure which coin selection algorithm they're actually applying to the playground. But yes, that when we see an error like that, even though the wallet clearly has sufficient ADA to make a transaction, that's why. Okay. And Jingles has been refining a coin selection algorithm here. And that's a really interesting advanced pathway for people to get to. It's not something that we can meaningfully cover within this 10-week course. But for anybody who really wants to keep geeking out after this course, like that's something that would be really fun to look at together. Okay. And coin selection just refers to selecting the right UTXOs from a wallet as inputs so that all the outputs are achieved, but often the good coin selection algorithms do take some other considerations into account, like minimizing the number of UTXOs in a wallet or minimizing the amount of Lovelace that's in a UTXO that holds other native assets, for example. Let's look at this code. So, and you can pull this as well, right? You can git clone this URL right here if you want to open this up in a browser. I'm just going to explore it right here. Or sorry, if you want to open it up in a code editor like VS Code. But I'm just going to stay here in the browser and explore this a little bit. So there's two packages provided in the repo. One is the module itself, and this is what feeds the NPM package. Actually, the more up-to-date one is the smart contracts one. Yeah. So look, the main branch of this repo was last updated 15 days ago, but the smart contracts branch was updated just yesterday. And so the latest release on NPM is going to be coming from this branch right here. But once again, in packages, we've got these two directories, demo and module. Module refers to the NPM package that I, for example, am using in the front end template. The demo is what's presented at the playground. And this demo, I think it's also a Next.js package. We can look at the package.json and yeah. So just like our front end template, this mesh playground is a Next.js project. And you can see that by just snooping around in the package JSON. And you can see the dependencies, and you can actually see that they haven't even upgraded their own playground yet. They're still on the beta 4 release, right? And so they've got a few changes I'm sure that they'll make to the playground as they move along. Now, because I know this is on Next now, I know that I can dip into the pages directory here to see the page that I was just looking at, which has the URL APIs/transaction. So I want to find an APIs folder, and then within it, transaction. There's APIs, and there's transaction. So this, just like our front-end template is introducing to you, has a series of components that are added to the page, okay? So what do we have here? creating transaction requires various steps, build the transaction, etc. This just helps me get situated on the page. So where are we? Where does it say creating a transaction? That's at the very top. Okay, so we're just reading this bit right here. Good. And then they're using this code block right here. To hold a code snippet. And here's each of those possible code snippets. And then we've got here, this is, what's the default export here? Export default transaction, yeah. So this is the main thing. This is what's being exported. And it's actually the showcase here that we're interested in. So showcase is going to be everything starting here and below. And so that's probably going to be much more interesting to us. Showcase consists of 3 components that are imported up here: send ADA, send multi-assets, and lock unlock contract. We were just looking at the send multi-assets one. So let's navigate to that. Send multi-assets is in a folder called components, and then transaction, and then send multi-assets. Oh, guys, can you hear me okay? I'm just seeing A's message. And Nelson, Lucas, I'm glad this is working. Yeah, it's good to
I
hear.
can hear you.
Okay.
Yeah, audio's perfect.
It was on my end. For some reason, like, yeah, sorry. It was all like I tried to do a whole bunch of stuff, but I've finally worked it out. A headphone issue.
Cool.
But yeah.
So if I was, one advantage of doing this in my code editor would be I could just hold Control and then this file, this component name right here, and VS Code will jump me directly to the file with this component in it. But it's not going to take me too much time to navigate to here. Again, I want to navigate to components, transaction, send multi-assets. Nothing else on this page really matters too much to me, so I'm okay navigating away from it. So let's go to demo, components, transaction, and here's send multi-assets. Again, look at this list of imports, right? So this really is, this is the best of building on React, okay? When React was first introduced by Facebook, it really was a revelation because it allowed people to componentize their front ends in a way that just felt easier than before. And I'm sure some people disagree with that. But you know, it's become one of the primary front end development frameworks because of this piece, right? It's straightforward to break your project into reusable component parts. And so you can see from this list of imports at the top, only a few of these, right? So I'm importing from React on line 1, I'm importing from Next on line 2, and then on lines 9 and 10, I'm importing from Mesh. But every other import here, lines 3 through 8, and lines 11 and 12, all of these imports are just from elsewhere in the very same project. And so we'll be able to navigate and find those things if we need to. So let's situate ourselves once again in the code. Send multi-assets is a card. Card is imported just from their basic components. Okay, so in our front end template, I'm using Chakra UI just so I don't have to take the time to build our own components from scratch. Okay, and that's just an efficiency decision right there. But if you want even more fine-grained control, You can always build all your own components from scratch. And you can see that's what Jingles did here. He's got this card. Okay. And so what we see here is just wrapped in that card component, whatever symbol that is, and you can review that on your own if you're interested. We've got this heading that says send multi-assets, similar to sending ADA. Let's just make sure we can see that. There it is, send multi-assets, similar to sending ADA. Great.
James, may I just quickly throw something in there?
Yeah.
Just on the topic of UIs, I've been messing around with headless UI, you know, within the Corona space for a while. We've been talking about like headless apps and stuff, and especially, you know, now that we're talking about wallets, I think, you know, it's useful to just kind of, you know, poke one's head into that. They've got React and a Vue implementation of this, basically this, I suppose, framework, which is fundamentally headless. And basically, yeah, like at a higher level, like it will allow for, you know, folks to customize their own sort of experiences whilst maintaining the underlying code, which, you know, would be secure and sort of implemented in a verifiable way. But yeah, I just wanted to sort of throw that in as an additional option there to consider.
That looks really cool, actually. Yeah, I want to rebuild the gimbal, treasury, and bounty escrow DApp from scratch, and maybe I'll play with headless UI instead of Chakra for that one. And that's a project that we'll all have the opportunity to get in on in the second half of this course. That's coming real soon. So the key thing I see here is the code demo. And this, you know, this grid 2 columns right here, okay? Column 1 is going to be this bit, this div, and column 2 is going to be this bit right here. And hopefully you can see on the front end, we've got this column is column 1 that has just the heading and some initial details. And then column 2 is on the right, and that's going to be our code demo. So the code demo is what we're really interested in. Now this code demo has this use wallet hook. And this deserves its own live coding session, its own deeper dive. But I'm kind of thinking that it's worth saving this bit for when we start breaking out into different specialties in the second half of this course. If you're not, you know, dedicating time to specialize in the front end part, you don't really have to understand this far, but this is maybe the first thing we can explore for people who start to specialize in front end. And this can be customized. It's already been done in our front end template. But I just want you to see that. But here, maybe this bit starts to look familiar. Certainly we have this transaction service with initiator wallet, right? That's exactly what we saw in the code that I was showing you. But then it gets interesting. And this bit gets us to, Curtis, the question you asked, right? That kind of sent us in this direction. I was showing you just the static ability to say, okay, send some Lovelace here, send some Lovelace there. This block of code shows us how to use a loop to cycle through some arbitrary list of recipients, and for each one to add a transaction recipient to what we're building. And I haven't spent any time with this code yet, so I'm seeing it for the first time, just like you are, to see how they built that front end. For each recipient in the list of recipients, Where's the form? Where's this add recipient button? Add, remove. So we got, there's a bunch of subcomponents within this same file. And here we go. I forget when I first introduced mapping over an array, but this is what we can see right here. Right? We're taking the list of recipients that comes from this series of forms, and we're mapping over that list. And we're creating a way to add each. We've got an add recipient button that on click calls the add function. The add function was defined above. Add creates an array of new recipients that consists of the old list of recipients, and then it pushes onto that the newest one that we want to add there. And that way you can dynamically be updating, this sample code down here as you go. I'm moving. I'm not really sure how deep to go right now. I want to keep this accessible to everybody and just give you this exposure. But obviously, in the next few minutes, a full deep dive into JavaScript and React is not possible. But Curtis, does this at least make some initial sense about how we might dynamically handle the building of those transactions?
Yeah, that looks good to me. Thank you.
Yeah, man. No, this is fun to get to look through this together. And if anybody else ever wants to do like a live walkthrough of code, I hope that you would feel confident to do so. Like I'm as much of a prankster here as anybody, just trying to learn enough to get by day to day. And so if anybody here wants to try their hand at walking through some code and helping us gain some insight, I think it's such a wonderful way to learn together.
Just a quick point of clarification. In the chat, I don't. You might have already covered this during my audio issues, but in the chat, there was some conversation about the size of metadata versus transactions. Could you actually just, I suppose, get clarity in terms of, because from my understanding, metadata itself, you've got max of like 16 or and yeah, but then in terms of the transaction, I believed it was a little bit larger than that, or I don't know, have I sort of got the wrong end of the stick here?
Does anybody know the definitive answer to that?
Sorry, I know it's kind of loud here, but based on what I'm finding with SnapBrillia, 64 kilobytes is the size limitation for the transaction itself. And then in the metadata, as somebody mentioned, there's no limit to the metadata, but it has to fit within the transaction. So the metadata in total has to be less than the 16 kilobytes. but each key value can be no more than 64 characters long. That's my understanding.
That makes sense to me, and that matches my experience. I have a confession to make, but it's also a philosophy. You know, I was a high school math teacher for a long time, and I learned that being a good problem solver and being fast at multiplication or memorizing facts is not the same thing as problem solving. So I'm actually not a person who memorizes facts like that. I just Google it every time I'm wondering about it until I remember it. So I'm really focused on kind of the problem solving development part of Cardano development, but I'm not usually going to be the person you can come to like get that quick recall. So sorry about that. Yeah, Don.
I was just saying a helpful thing, like I do mint where I'll have like, you know, multiple things that I'll have to mint, and I'll just have one metadata file, and then I'll just have like all, you know, like 20. And if I need to mint one off there, or if I need to mint two off there, I use the same metadata file. So that's what I wonder about that, because occasionally I will get where it's like, no, it's too big. It won't, you know, it's not going to work. But just for being able to use the same file and reference individually, I really love that about this chain, and just with the metadata conversation.
And we could push that limit right now, right? Like as an exercise, we could just build a transaction with metadata attached, and we could just keep eating, like, you know, copying blocks of text to that metadata until it objects. So that's another fun thing. But the thing I want to do now before we close out for today is just expose you to what a smart contract transaction is going to look like. And this is my development task for the rest of the day. I might be able to drop into like one of the live rooms in Discord in a little while. But I want to finish this up, integrating the latest changes to Mesh before releasing this module of the project, where we actually look at those smart contract transactions. But let's just get a preview of what that's going to look like. I have a faucet locking component in development and a faucet unlocking component in development. Okay. Uli, that's a great way to query. Yeah, query protocol parameters, and there you have it right there. Beautiful. Max TX size. So let's look at a locking component and an unlocking component. Locking, I'm going to find the part that looks familiar to me. Here it is. And you can see there's not much to this. This is not much longer than the just asset sending transaction I was showing you a few minutes ago. We still initialize a transaction. This time using send assets instead of send Lovelace or send value, but that's a choice. You could use send value if you wanted to include a particular amount of Lovelace in this transaction. And what do we take? A contract address, which is hard-coded actually into the project. More on just the JavaScript part of grabbing different addresses. We're gonna need to do this as people start building their own. Okay, but that's just stored in a different file that happens to be called faucet integer for now. Okay, now, you know, you can talk about how dynamic an app should be and what should or shouldn't be hard coded, but a contract address, at least the way I see it, is likely to be hard coded more often than for, you know, for example, an amount or some receiver address, you know, like some other wallet address, because the contract address specifies what the dApp is doing in the first place, right? So many dApps are going to have hard-coded addresses like this one. Then there's the value we're sending. That's a variable called lock assets. What is lock assets? It's an array of values, just like we saw in the front end a few moments ago, right? So square brackets are an array, curly brackets are an object. This particular object has a unit called faucet asset, which is defined right here. And this, I would want this to match the asset that I used as at compile time in my Plutus script yesterday, right? As the native asset that I want to be able to distribute here, right? But this can be dynamic too. And in the end, this faucet project that we're building is going to have to make this part dynamic because each one of us is going to be using a different asset. And then finally, I identify an integer for datum because that's what my contract requires the datum to be. And this integer can be anything, right? Any number. And that's included right here. And look at this. We've talked about how failing to include datum on a transaction is going to permanently lock some value at a contract address. And I'll admit that I've done this as I've been experimenting. I have forgotten to add the datum to the output that I'm building right here and have inadvertently locked some funds. And so this is another thing, right? Like when we're checking our apps, this is the kind of thing. If I include this bit right here, I'm safe. But if not, there's nothing forcing me to include it. Notice that this datum bit is just an optional field of this send assets function, okay? I can send assets with just an address and a list of assets, or optionally, I can include some datum when I need to. Okay, so Yuli asks, where's the Plutus script? Let's bring this back to yesterday. In a locking transaction, all I have to do is send to some contract address and include some datum hash. It's not until I try to unlock that I actually need to read the Plutus script itself. So where's our Plutus script? We're not going to see it referenced in the locking transaction. But when it comes to unlocking, this is the transaction that we can expect would need to be a bit more complicated. Check it out. This is it. We still initialize a transaction service. We're still using a wallet, a browser-based wallet for now. And now there's this new function here, redeem from script. I'm going to come back to this in just a moment. After we successfully redeem from script, sending assets looks exactly the same. I'm going to send some assets back to the address of the connected wallet. And I'm going to send some certain assets that are specified up here, assets to sender. This is not made to be dynamic yet. That's what I have to work on this afternoon is just turning this into a variable that can be automated, okay? But we can see, okay, sending assets, that still works the same. And we can tag on another send assets to that sends essentially the change back to the contract address with some other specified value, assets to contract. And don't forget that that one's going to need some datum on it. Now, the send assets to sender, look closely at this. Assets to sender has the 5,000 tokens that I might try to be claiming from the faucet. And then it also has this other one thing this PPBL summer 2022 token that's required by the contract in order to validate. But again, compare this to yesterday. Yesterday, I had to look at all my UTXOs and find one with an auth token in it. Now that I'm using the front end to orchestrate these transactions, all I have to say is, in the output, I want there to be one of these assets, and Mesh takes care of coin selection, choosing a UTXO, if available, that has this asset inside of it, and then returning it as output to me. And I got to be honest, this feels a bit like a miracle and a bit like magic to me. I can write that Plutus code. I can write that validator that only validates if this, this, and that. And then all I have to do in my front end is make sure that the appropriate outputs are included in what I want to send. And under the hood, this library is going to select those assets. And if it does, then my script will validate. I think that's pretty incredible. So last thing for today, redeem from script. In this case, it doesn't take an address, okay? It takes a UTXO, a script, and then some of this is like, I forget what they call this under the hood, but this object right here has inside of it my datum and my redeemer. Okay, I'm going to leave this aside because we're going to talk a lot more about datum and redeemer as we start building really powerful business logic, right? This faucet doesn't even use these yet, so I'm going to ignore this for just a moment, but let's focus on the faucet UTXO and the script for just a second. Where is faucet UTXO defined? All right, it is, where is it? Yeah, so what I did here, sorry, I got to get myself up to date on where this query happened. Oh, that's what I did. Okay, so I built a separate component here called get the UTXO from Koios. And this just makes a call to this Koios endpoint. So I can pass the address of the contract to this function. And then what it's going to do, it's going to return to me all of the UTXOs, right? This says the array of UTXOs that are found at that address. And then this bit right here just makes sure to format what Koios provides into the format that Mesh expects. Okay, so the way Mesh represents UTXOs is with an input and output, a TX index and hash, and then the address where that UTXO lives, the value stored in it, and if it has any, a datum hash. This data type is also ready to handle some of the V2 features coming soon, like reference scripts, but we're going to get there together. All right. But when you look at the unlocking component and you see that it takes a UTXO and not an address, the reason for that is that the owner of that UTXO, the address where it's currently held, is actually part of that UTXO object itself, okay? So that's that bit. I'm trying to make short work of this to not keep us here too much over time, okay? But that's something we'll touch on more. Pulling that UTXO, hopefully you can see the importance of querying the blockchain. Every time you interact with a contract, you have to query the blockchain, right? Because you don't have a wallet hooked up like we can with NAMI or Eternal that shows us what's in that local wallet. This contract is by definition remote from you, the user, and therefore we're going to have to query it somewhere. So after we build that UTXO and we can pass that along, for example, we can call it the faucet UTXO. Finally, we add the script here. Okay. Now this script, this still blows my mind that this is how low tech this solution actually is. Watch this. This is imported as script integer.script. Okay. I called it script integer because we were using integers as datum and redeemer, but that's imported here. There's a folder in this project called Cardano Plutus, and inside of it is the faucet integer. Cardano, Plutus, faucet integer. But look, I want to tell you how high tech I was right here. What I did to make this file is I compiled a Plutus script and I used old-fashioned copy and paste to go from my output from compiled Plutus that looks like this. I just took this whole string right here. I Control C and I put it in this file right here. Okay, that feels incredible and a little bit ridiculous to me that all this high-tech stuff all relies upon me copying and pasting this string of encoded text right here. Okay, but that's how it works. Okay, in my front end, that script is stored here as a long string. It's 7,000 characters or so. Okay, and then it's accessible within my logic. And that string is what I'm passing as the script right here, which is then deserialized so that it can be used for logic. And my transaction validates or it doesn't. Yuli, thanks for laughing at that. Because I'm laughing at it too. I appreciate that. All right, but it's crazy, but that's where all of this gets us to, right? All of that work just to copy and paste a string of nonsense into a JavaScript project. Incredible, huh? Okay, so now to the chat. If another person wants to unlock, how do they get the Plutus script? Excellent. All right, I'm going to give you the V2 answer first. After the Vassal hard fork, and as we start using Babbage era functionality, people will be able to use each other's Plutus scripts just by telling each other the reference for it that's already on chain. That's incredible. That's an incredible upgrade. Right now, if another person wants to use that script, they got to share the string somehow, some way. And that's what you're going to do in this project. In part, I just want to piss everybody off and get you kind of excited about Plutus V2. Okay, but just to get excited that what we've had to find kind of back doors in order to accomplish is with this upgrade about to get much easier. But, you know, we've all heard those stories about how way back when people used to have to walk, 15 miles through the snow to get to school. And we're doing the equivalent about that right now. Okay, we're going to do this the hard way first so we can appreciate the upgrades. And what we're going to do is in part 4 of this faucet project, you'll add your compiled Plutus script to the front end repo. And then we're going to be able to import all of those scripts and select the one that's relevant to whatever faucet people are trying to use. Okay, so one time doing this the hard way, and then let's upgrade this thing together. And then where are we initiating the contracts? How do we connect the button for the end users. Okay, good. Let me just show you what this looks like in the end, right? I'm going to run Young Dev here. I'm not totally sure this will work right now. Actually, I know this contract is empty right now, but at least we can look at what it looks like on the front end. So let's do that. And then we'll call it a day after this. Okay. So there's a route that's not yet in the nav bar up here, but there's a secret route called faucets. Okay. I can connect to a wallet. And yeah, there's just an unlock button right here. Okay, you can just build a button, and in the source code for this component, which was just open on the screen, and you can review it, is the button, and then there's a function called I called it handle unlock tokens, which is kind of the standard, right? Handle, and then the verb, what you want to do. I want to unlock tokens. Okay, so this button is going to initialize that whole thing. It should give me an error right now. Oh, look at that. That's funny. Hold on one second. Let me just show you. I declined to sign it. But let me share this a different way. Portion of screen. All right, watch. So it still works in that my wallet does open up when I tap this unlock button. I don't know if it would validate or not. But let's look at the details, right? It knows it's a contract. It knows there's a datum involved. Yep, I'm trying to claim 5,000 TPBL test gimbals right here. The one thing that's funny to me is that it doesn't even acknowledge that I am sending my PPBL summer 2022 token to myself, right? Because that token is part of the transaction that we're trying to sign for right here. But because it's just being sent to myself, that doesn't even show up as being received or sent. We just see that we're receiving 5,000 of these tokens from the faucet. And you'll see the same because you're about to start building this very same thing for yourself. I don't think this is going to validate, but let's find out. No reason not to try. Yeah, wallet could not send the TX. That's because some of my redeemer and datum logic needs to be fixed because I'm kind of in between transactions right now. But we'll get that working. Yeah, the new way that these tools allow transparency and verifiability, and at the very same time security, right? Like anybody can read this contract, even if the Plutus code itself is closed source. The contract is out there, right? People can find that, and if you're good enough at decoding or deserializing things, you can figure out what it says, right? But that's not the interesting part. The interesting part is that even though there's no privacy in terms of what the business logic might be, the security is, hey, you can only do this if you hold a token. You can only claim from this faucet if you hold a PPBL summer 2022 token. And the Cardano blockchain is not going to screw up. There's going to be some high profile hacks of quote unquote Cardano over the next 5 years. They're going to be huge. And if you're an investor in anything related to Cardano, it's going to hurt when it happens. Okay. But every time those hacks happen, it's not going to be because this functionality doesn't work, right? I can gate access to a contract trivially with a token. The harder part is the human part. How do I make sure that only the people who I want to have those tokens are going to have them? Right? How do I make sure that that token isn't falling into the wrong hands? These are the much more interesting problems. How do I build the intermediate services that are required to query a blockchain in an uncorruptible way? You know, it will be a really good hack for this contract right here would be just to slip in somebody else's address, right, for some outputs without anybody noticing. Although I guess that part wouldn't be possible without the token, but that's the idea. I see Curtis and A.
I love the theoretical thoughts that you're going down. Those are awesome. I feel like I maybe missed something. Why did you need to send the token to yourself? Is that the way the Plutus script is validating that you have it?
That's exactly right, right? So the Plutus contract says that the PPBL token must be included in some of the input, and it must be in an output that is sent to the sender of the transaction. And so without that, this thing wouldn't validate.
Now, is that the way you built it, or is that every case where a script needs to validate that you have a particular NFT or token, that you have to put it in input and output? It doesn't just query that wallet address and see that it's there in some UTXO?
I'm so glad you're asking that question. And a lot of us have been asking that. Like, I remember when I first learned this stuff, it was shocking to me that that was just impossible to look passively at a UTXO. I was like, that can't be right. Why can't I just look at it? And much longer story short, that's the functionality that we are about to get with this upgrade. The ability to look at a UTXO without consuming it. And yeah, dude, it changes everything. It really changes fundamentally, because yeah, for now, Plutus V1, Alonzo era, that's the way you do it. You consume it as an input and you make it an output.
Okay, so you're connecting dots for me, because I was aware that yes, you couldn't look at a UTXO without consuming it. That, okay, now you're making sense to me. But I thought for some reason you could at least query, a wallet address and see UTXOs and then see that it's present. I thought the limitation was you can't see the metadata or the datum inside of it. Sorry,
Well,
the
okay,
datum.
so quick distinction there, right? Yeah, like I can query, I can look at stuff on chain, but can I use it in my Plutus logic is a different question. Okay.
I see.
And so the Plutus logic could only see UTXOs that were being used as input or output to a transaction. And that's why this constraint existed. And it is a hard problem to solve for. If you can do something just by looking at something, how do you prove ownership of that UTXO? That's kind of what had to be solved for to make these upgrades possible. And that's a big part of what was discussed in the CIPs that are being implemented right now. And metadata the same way, right? I can look at metadata anytime, but there's no native way for Plutus to reference that metadata. That doesn't mean I can't build a dApp that looks in metadata for data to be used as redeemer or datum. Does that make sense?
Yeah.
Right.
Yeah,
I can build a transaction orchestrator that requires datum and redeemer. And where is it getting that data and redeemer from? Oh, it can look at metadata. It can query that. And then it can pull that into a transaction. And now, in effect, that metadata is contributing to my validator logic. But the only reason it's able to is because I took that extra step in my orchestrator, in my PAB, or in my front end to grab the data and then to pass it as datum. Hey, sir. Oh, you're muted, I think.
About now, can you hear me?
Good. Yeah.
Okay, you see the issue is, can you still hear me? Okay, you got, okay, cool. Uh um yeah, I've been having, again, audio issues, apologies. Yeah, I just want to say three quick things. First is wallet versus address. Like, it's occurred to me that a thing that wasn't clear to me a while back is actually still not clear to, I suppose, like folks still, maybe older folks, but also like newer folks, is that like people tend to use wallet and address interchangeably when actually technically they aren't really the same thing. Like the wallet is a superset of of the um of the address, right? So a wallet has a whole bunch of different addresses, and in certain cases, for example, with the logic, like James pointed out, being able to tell if an asset is inside an address needs for certain constraints. For example, NAMI has this constraint where it only like allows for a single address, um, as far as I know. And this makes it easy, right? Because you're not sort of, having to deal with a whole bunch of different addresses. Because the default, for example, Daedalus has, allows for a lot more addresses. And this obviously has aspects, privacy related aspects. You get some and you sort of, I suppose, lose some to some extent. So you gain some interesting functionality and you lose in the context of privacy. And there are other sort of, broader conversations to be had there that I think are interesting and, ought to sort of, be had as we sort of gradually walk along this awesome journey. The second point is I was curious about I suppose this kind of goes back to like asking what is a wallet, right? Like, because technically a wallet is simply something that can allow for you to sign a thing. And so in this particular instance, as we're talking about mesh directly fetching data back and forth from the chain, in this case using Block Frost. I always forgot the name there. Obviously, that's interesting, and you can sort of introduce some sort of caching type mechanism in using a quote unquote wallet in the sort of interim in the middle between the application and chain. And ultimately, you would need some way for the transaction to be signed. So a wallet will need to come, a function of a wallet in this case that has to do with signing will need to kick in at some point. So that's it's interesting to think about like what's more efficient. Do you want to just like have this intermediary that's kind of caching some queries and maybe even some logic that kind of makes the application a little bit lighter. And then finally, the headless UI thing that I mentioned, I've actually been looking at a Svelte implementation of it. I just really, like Svelte in how it sort of goes about things and how light it is and just accessible it is. So yeah, if you're interested in looking into that, I think I would definitely be interested in hopping on that journey.
Hey, thank you for that. And yeah, just second everything you say. And I feel a lot of gratitude that we're moving into these deeper conversations now. And so hopefully anybody here who's been pretty new to Cardano, my highest hope is that your experience so far is such that a lot of what A just said is relevant to you. Hopefully we've gotten you there. And if we didn't get you there yet, let's keep working on that, okay? And whatever problems you're starting to find are most interesting, I would love to hear similar from everybody else here so that subgroups can start to form. that are going to be diving into these much more interesting problems, right? Everything we've done so far in this course is this kind of high level view. We're getting started, hopefully in an effective way. But the only way we'll know if all this was effective is if everybody here really feels confident about starting to specialize and collaborate more deeply with each other. And anytime you want to start a study group, go for it, man. That's the beauty of being here. And I really appreciate that. Thanks. All right. Well, we went the same amount of time over as yesterday. I guess maybe these live coding sessions, maybe we should just call them 2 hours instead of pretending they're going to be 90 minutes. But I appreciate people sticking around. It's really, really cool to see a core group starting to form. And thank you all for being here. I'm excited for where we're going together. Yeah.
Yeah, sorry, just quickly. I didn't actually realize that it's been 2 hours because on the website calendar it says half past the hour. Yeah, just I suppose a request if that could be updated, and if the Zoom link could be in there as well. I think that would be kind of helpful as well, because today I kind of had to ask someone helpfully actually sort of like, you know, put it in the chat when I asked. So yeah, if that could be updated, I think that would be super awesome. Thank you.
I'll update that on Team Up. For some, you see, the time is right for me when I go to the calendar. It's local time. These blocks are right. I can at least add Zoom, but if you can send me a screenshot of what you see, this Team Up team has, I don't know why I'm still using this tool. It's just inertia. So sorry about that. Hey, so real quick, next week is kind of our halfway point. And so we're gonna take a momentary breather, but really I recognize this is going to be a chance for people just to get up to speed. Okay, so by the end of the day tomorrow, the full faucet project will be posted. And there's a couple things I have to revise just because we've been moving so quick and developing the project right alongside Mesh as it's been rolling out in real time. So that'll be out by the end of the day tomorrow. And then we have next week for everybody to kind of get up to speed and to catch up with what you want to understand so far. So we're not going to have an official live coding session on Wednesday. Everybody can feel free to use that time to start jumping into self-formed groups if you want to. And if you want to seek people out, I'll put a message about this on Discord. But if you want to use that time, think about how to informally use the time where live coding would typically happen next week. And then on Thursday, we will have a live coding session, but we're going to use it as reflective time to kind of hear what's working so far and you know, what kind of questions or critical feedback you have about the course, and then to think ahead to, okay, what commitments can we all make for the next 5 weeks about what we want to accomplish by the end of the course. So that's the shape of live coding for next week and for intermission. And then we'll have 5 more weeks of every Wednesday and Thursday to keep diving deep together. Uli, thank you. And thanks for being here. All right, all. Any last words before we hop off? Okay. Appreciate you all. Have a great rest of the day. If I'm jamming on the front end and fixing up these contracts, I'll jump into a Discord live chat maybe in a couple hours. Otherwise, see you soon. Cheers.
Thank you so much.